Yeah. So auto scaling is the process of increasing, decreasing infrastructure based on the demand. What is that, guys? So it is the process of increasing, decreasing infrastructure based on the demand. Auto scaling can be done in two ways: horizontal auto scaling and vertical auto scaling. Guys, it is the process of increasing, decreasing the infrastructure based on the demand. So, guys, what is auto scaling? Guys, are you able to hear? Rafi, funny.
Yes, sir.
So, what is the auto scaling? It is the process of increasing, decreasing infrastructure based on the demand. So, based on the demand. So, for example, so this is your node, guys. This node having the three pods. This node having three worker node. This is the worker node. This worker node having the three pods. Okay. So, for example, your application will be deployed on this one worker node. Your application will be deployed on the one worker node. Right. The This is, for example, a WhatsApp app. What this is, guys? WhatsApp application. So WhatsApp application. So here less users are accessing. Yeah, the users are increased. What is that, guys? So there, for example, two users. For example, these users are accessing app. So it will be sustaining the user pod and the pods. The application will not hang. It will not hang. The people are increased, so it will be not sustaining. We need a we need a another we need a another worker node, and so we need a another worker node, and we need the again three apps. We need the uh, yeah. So again three so automatically automatically created another node and created the pods based on the metrics, guys. Based on the metrics. What are the metrics, guys? Based on the metrics means RAM and CPU. Based on the metrics, so based on the metrics, if the metrics are increased, the metrics are increased, it automatically it automatically created the nodes or parts. Nodes are parts, guys. So this is nothing but a auto scaling. What is it, guys? Auto scaling. So auto scaling means decreasing or increasing the infra, decreasing or increasing the increasing the increasing the nodes or parts. Nodes are parts. Guys, now you understood? So what is auto scaling? Decreasing or increasing the nodes are passed based on the guys, tell me, based on the metrics.
Metrics.
Based
Yeah,
on the metrics.
metrics.
What is auto scaling, guys? Auto scaling is a
Decreasing and increasing of nodes and pods based on the
so auto scaling is nothing but a increasing or decreasing the. nodes are passed based on the metrics. So fire, the people are also increased again. The people are also increased again. So again it will be creating again again it will be creating the parts and parts and parts. So this is nothing but a this is the this is nothing but a guys what this is? This is a HPA
Yeah.
horizontal pod
All.
auto scaling.
Yeah.
Horizontal pod auto scaling. This is nothing but a so instances will be increasing. So instances will be increasing. So vertical. So the other one is a HPA horizontal. So HPA is its horizontal pod auto scaling. VPA. The other one is the VPA. What is that, guys?
VPA.
VPA. The other one is VPA. Vertical pod scaling. What is that, guys? Vertical pod scaling. Vertical pod auto scaling. So vertical pod auto scaling means it will not increases the instances. It will increases the it will increases the it will increases the system or server or instance or VM configuration. Configuration. Guys, now understood? Configuration. So it is not using in the it is not using in the Kubernetes. Which one is using? The HPA is using in the Kubernetes cluster while installing the auto scaling. So auto scaling. Guys, now you understood?
Yes.
Okay. It is the process of increasing, decreasing the infrastructure based on the demand. Auto scaling can be done in two ways, horizontal scaling and vertical scaling. Horizontal scaling means increasing the number of instances or systems. Vertical scaling means increasing the capacity of the system. Increasing the capacity of the system. Horizontal pod auto scaling, vertical pod auto scaling. So vertical pod auto scaling, we don't use this. Okay. Horizontal pod autoscaler, which will scale up and scale down the number of pod replicas of the deployment or a replica set or replication controller dynamically based on the observed metric CPU memory utilization. CPU and memory utilization. HPA will interact with the metric server to identify CPU memory utilization of the pod. So for production, we will use the horizontal scaling. Horizontal scaling. Yeah. So horizontal scaling versus vertical scaling. So this is the vertical scaling means it will increase the capacity of the system, but the horizontal auto scaling is nothing but it will increases the instances. So which one is using, guys? Horizontal auto scaling or a vertical auto scaling? Horizontal auto.
Horizontal.
Autoscaling.
Yeah. So while horizontal scale refers to the add additional nodes, a vertical scale describes the adding more power to your current mission. More power. So more configuration. But in the horizontal scale, it adds the instances. It add the instances. Understood? Autoscaling is a way to automatically scale up or down the number of computer resources that are being allocated to your application based on the demand. Based on the demand. How HPA works, something like there is a metric server. So metric server, so it will check the HPA memory and CPU utilization on the target. If HPA is if memory and CPU is in, the utilization is very high, so it will automatically scale up the pods. So increasing the pods. The setup auto scaling setup is step one, install metric server. Step two, deploy sample app. Step three, create a service. Step four, deploy HPA. So increase the step five, increase the load. Monitor the HPA events. Auto scaling, more users accessing the app, less users accessing the app, guys. Less users are accessing the app. Guys, understood? Now
Yes,
you
bro.
guys are understood, right?
Yes, sir.
But auto scaling, auto scaling, how many types, guys?
Two types, horizontal
Two
autoscaling
types.
and vertical autoscaling.
Horizontal,
And vertical autoscaling.
mm, horizontal pod auto scaling, and the vertical pod auto scaling. Horizontal pod auto scaling and the vertical pod auto scaling. Mm. 1 second, guys. I'm opening the this one. So horizontal pod autoscaler, which will scale up and scale down number of pod replicas of the deployment, replica set or replication controller. HPA will interact with the metric server to identify the CPU memory utilization of the pod. So, so what are the commands, guys, to see the metrics on the 1 second. Yeah. How, what is the command, guys, to see the metrics? Keep CTL top nodes, keep CTL top pods. So we already discussed in the previous class, right, guys? We already discussed in the previous class, right? One
Yeah.
second. So we installed the metric server through the Helm charts, right? I'm using which user, guys? Funny, right? Funny.
సార్
Huh?
అది క్లస్టర్ క్లోజ్ చేశాను సార్.
Why?
అది బిల్లింగ్ ఎక్కువైందని చెప్పి క్లస్టర్ క్లోజ్ చేశాను సార్.
అది మనం మెయిన్ పెట్టొచ్చు. క్లోజ్ చేసావా? రఫీ, నువ్వు ఇన్స్టాల్ చేసావా? రఫీ,
నాది కూడా బిల్లింగ్ ఎక్కువైంది బ్రో. నేను ఆల్రెడీ మెయిల్ డ్రాప్ చేశాను.
చేసావా?
రెస్పాన్స్ కోసం వెయిట్ చేస్తున్నా.
బా, ఈ కేసు తీసేసావా? బిల్లింగ్ ఉందండి దానికి? ఫనీ, బిల్లింగ్. 37.23 మెయిల్ పెట్టు వాళ్ళకి. రఫీ
2037 బ్రో, నాదైతే 57 ఏకంగా.
ఏం కాదు మెయిల్ పెట్టేసేయండి.
నేను మెయిల్ డ్రాప్ చేశాను ఆల్రెడీ, వెయిటింగ్ ఫర్ ద రెస్పాన్స్.
ఓకే, సపోర్ట్కి పెట్టండి, మెయిల్ పెట్టేసేయండి. ఓకేనా?
యా నేను పెట్టాను ఆల్రెడీ.
సో ఒకసారి సపోర్ట్కి వెళ్ళి ఇట్లా నేను స్టూడెంట్ని, సో ద ప్రాక్టీసింగ్ పర్పస్ ఐ యూజ్డ్ ఇన్
నేను
కేస్.
నేను అట్లానే నా ఐడి కార్డు కూడా ఉంటే ఐడి కార్డు కూడా సబ్మిట్ చేశాను, కాలేజ్ ఐడి.
సరే, సో మనం ఏం చేయలేము, నాది కూడా లేదు. సో kubectl టాప్ నోట్స్ అండ్ kubectl టాప్ పార్ట్స్, రైట్? So how you can check the to get the nodes of the node matrix, how you can check it, guys? Matrix, so we can use the kubectl, guys, speak out, kubectl top nodes, kubectl top parts, kubectl top nodes, kubectl top ports to get the parts matrix, kubectl top parts to get the node matrix, kubectl top nodes. So note by default metric service is not available. So by default it will the metric service is not available. You can add on. You can install the add-on. Metric service is an application that collect the metrics. Metric server is an application that collects the metrics from the object, such as pods, nodes, or according to the state of the CPU RAM, and keeps them in the time. So metric server can be installed in the system as an add-on. You can take and install directly from the repo. You can take and install file from the repo. So you already knows, right, how to install the metric server API. We already discussed. So something like clone the git repo, git clone, check the cloned repo, that Kubernetes server, ls deploy, apply manifest file from the manifest server directly, kubectl command. kubectl command will create a service account, role, binding, all the stuff. So we can see the metric server running on the kube system. kubectl get all -n kube system. So to top the nodes using the metric server, kubectl top nodes. To see the metric pods using the metric server, kubectl top pods. So when we install the metric server, it is installed under the Kubernetes namespace. Kubernetes namespace. So the deployment file, guys. A sample application, deploy sample application. Deploy the sample application API version, the kind equal to deployment, metadata, name HPA, demo deployment, spec, selectors, match labels. So match label is nothing but what is this, guys? So match label is nothing but a replica set. So replica set, replication controller. So replication equality of a set and set based set based replica set. Something like what is the match label? Match label equal to run HPA demo deployment. So replicas one, the template metadata labels HPA demo deployment. Spec containers. What is the container, guys? The container is HPA demo deployment. What is the image of the container? Image will be taking from this HPA example K8s gcr.io. What is that, guys? K8s gcr.io. Yeah, this is the artifactory registry. Try it for free. Yeah. Yeah. So it is from the artifactory registry. So the next generation of container registry managed by the so this is the Google Artifactory registry, guys. What is this? So this is the Google Artifactory registry. As the evaluation of the container registry, artifact registry is a single place of your organization to manage container images and language packages. So it is fully integrated with the Google Cloud tooling and runtime, and comes with the support for a native artifact protocol. This makes it simple and integration it with the CI/CD tooling of the automated process. Okay, supports equal to 80, resources equal to so here guys, here this is the new component, the resources. So what is the resources guys? Resources are limits and requests. Limits and requests. If the limits is CPU 500, the resources and requests. Kubernetes resources. So understanding the resources and limits, requests, resources. In the resources, Kubernetes best practices, resources and limits. So requests and limits. So request. So this is the request is nothing but limits is nothing but a minimum. Request is nothing but a maximum amount of the CPU. What is that? Limits and requests. So these are the mechanisms Kubernetes uses to control resources such as a CPU and memory. Requests and limits are the mechanisms Kubernetes use control resources such as CPU and memory. So requests are what is a container is guaranteed to get. If the container requests resources, Kubernetes will only schedule on a node that can give it the resource. Limit, on the other hand, make sure a container never goes above the certain value. The container is only allowed go to up to the limit. So then it is a restricted, guys. So this is the request is the minimum CPU and the maximum CPU is the limit. So maximum CPU is a limit. So guys understood?
Yeah,
So
bro.
requests limits. So underscore image request equal to 32 memory CPU equal to 200. So memory CPU limits equal to memory 64 gig CPU equal to 250 M. So request is nothing but a minimum, limits is nothing but a maximum. So request 32 M and CPU 200 200 milli memories. Limits 64 memory and CPU is 255. So request is minimum, limits is maximum. Limit is maximum. Guys understood?
Yeah, bro.
Yeah. Limits and requests are are important settings when working with the Kubernetes. This article will focus on the two most important ones, CPU and memory. Kubernetes defines a limits as a maximum amount of the resource. A requests on the hand are the minimum guarantee amount of the resources. Now you understood, guys. Kubernetes define a limits as a maximum amount. What is the guys? Limits is a maximum amount and a request is the minimum account. Guys, here request is a minimum amount. Is not a minimum. Sorry. So minimum So this is limits is nothing but a maximum. Yeah, guys. So once it is maximum crossed, the CPU maximum crossed, it automatically create the another pod. Right, guys? The minimum request, if the pod is increased, something like the pod is increased, the request, the CPU is decreased to 200, it automatically decrease the scale, decrease the pods. That is the resources limits and request. Kubernetes define limits as a maximum amount of the resource to be used by the container. A request, on the other hand, are the minimum guaranteed amount of the resources that is reserved for a container. A container, a minimum is 200, a maximum is 500 M. Understood, guys?
Okay.
Yeah, so that is a CPU, a limit to request. Request is 1 GB and the limit is 2 GB. A request guaranteed 1 GB of CPU, a limit is guaranteed 2 GB of CPU. 2 GB of CPU. Guys, understood? Limits requests. In the limits request, we can give memory CPU. So limits request. So what is that? The resources. In the resources, we can provide the limits and requests. In the limits, we can create a memory and CPU, and the request we can create a memory and CPU. Memory and CPU. Guys, understood?
Yes, bro.
Very good. Memory and CPU. It requests memory and CPU. 1 second, guys. Requests, request and limits. So limit is a maximum amount. Limit maximum or request maximum. Guys, so limit is nothing but a maximum amount.
Request is the minimum.
Mm. So here see, guys, request and limit. Limit is the maximum amount. Request is the minimum amount. Okay. Yeah, I will tell you once. Yeah, so we created the limit and request. Once we created that, kubectl apply -f deployment. So then kubectl get to deploy the service account, guys. So you already know, right? Service account, how to create the service account, how to create the service account. Something like a service we can, so we can create a service, the service deployment, service name, label, you can create, right? A kind equal to service. So then you can create the service also. What you can? So you can create the service. For example, so this is the create a service. So kind equal to service HPA demo deployment, run HPA demo deployment, that HPA demo deployment, guys, kubectl apply, get SVC. So this is nothing but a HPA. Yeah. So now we created the deployment dial for so this is for the sample application. The sample application replicas is equal to 1, and the limits, resources of the limits, so minimum maximum we set, service account we created, service deployment we created, then horizontal pod auto scaling, the spec, scale target references, the scale target references, kind deployment, demo deployment, min replicas equal to 1, max replicas equal to 10. So target CPU utilization percentage equal to 50. So what is that, guys? Next, so we will create the HPA horizontal pod autoscaling. So what is that, guys? API version autoscaling v1. So kind equal to horizontal pod autoscaler. Guys, here. So kind equal to horizontal pod autoscaler. Metadata and spec scale target reference. What is that, guys? Scale target reference equal to API version apps v1. Kind equal to deployment. Name equal to HPA. It will target to the this one. It will target to the this one. Okay. So once it is done, so target to the this one and min replicas. Min replicas how many, guys? One min replicas, max replicas equal to 10. So we can create the 10 parts based on the increase. The target CPU utilization percentage equal to 50. So target percentage equal to, if the CPU memory, if the CPU 50% above, so in the, so here if the percentage is 50%, something like uh, 500, right? So 200 is equal, 200 is a minimum, maximum is equal to, so 500. Something like if it will process what is the 50% to 50 M CPU, it automatically scale up the parts. It automatically scale up the parts, the target CPU. So next, increase the load. Increase the load. So if increase the load, kubectl get HPA, kuberun target load generator image box busy. So we can get it after executing the load generator. Open duplicate to tab monitor HPA events. So we will deploy it. This one, guys. What is that? kubectl get HPA. So the horizontal pod scaling, kubectl run -tty, load generator rm image. So busy box, restart never. So then bin sh while sleep 0.1 to wget. So this is a HPA deployment done. So then after executing the load generator, open duplicate tab to monitor HPA events. So get the HPA W. So to get HPA-W, kubectl describe deploy HPA demo deployment, kubectl get HPA, kubectl get events. Guys, understood? Kubectl top parts, kubectl get WA. Yeah. So Kubernetes web dashboard, we can communicate with the Kubernetes cluster in two ways. One is a CLI, the other one is the a web-based dashboard. So right. So the dashboard. So which one we are using, guys? I already showed you, right? The Kubernetes a web dashboard. So Kubernetes web dashboard. This web dashboard, we can communicate with the Kubernetes cluster in two ways, guys. So we can communicate the cluster in two ways. We can communicate with the Kubernetes cluster in two ways, right, guys? Kubernetes cluster in two ways. So one is so what is one, guys? So how you can communicate with the cluster, guys? So this is your Kubernetes cluster. So there are two ways to communicate with the cluster. What is, guys? kubectl. kubectl. So this is a CLI. And what is the other one, guys? How you can communicate with your Kubernetes? So one is kubectl. The other one is, guys, tell me. Sorry,
kubectl
kubectl CLI. So the user interface GUI. So how you can connect open lens? I already showed, right? The open lens, or we can so web using kubectl we can execute the commands to deploy our components in the Kubernetes cluster. The web dashboard we will provide our user interface to perform our operations in the Kubernetes cluster. So here also we can use the same, we can do the same operations. Here also we can do the same operations. So this is the UI, this is the CLI. This is the UI, this is the CLI. So what is? Mm, so what are those? kubectl, kubectl. This is a CLI. kubectl is CLI. The second one is web dashboard. Web dashboard UI based. UI based. Example. Guys, tell me example. What is example? Open lens.
Open lens.
So we can use the third party tool open lens and so we can configure kube config, right? So we can configure with the kube config and then we can communicate through the open lens. We can communicate through the open lens. Yeah. So here, right? So for example, we can, so it is not communicating because of it is already deleted. So like for example, if you click here, it automatically opens the open lens, open lens Kubernetes. Yeah, here guys. You see? So this is the way we can see it, guys. Here you see parts, right? Here we see parts. Yeah. Here you see. Yeah. So this is the open lens, something like here you see the parts. So parts, the deployments. So you can go to the pod and we can restart it. We can do it. This is the a dashboard. So this is the a dashboard for the Kubernetes. Guys, understood? Yeah. So we can provide the kube config. So using kubectl, so we can execute, guys, we can execute commands to deploy our components in K8s cluster. Yes, right, guys. K8s cluster. In the dashboard, we will provide the user interface to perform our operations in the Kubernetes cluster. Web dashboard. Web dashboard. So web dashboard will provide user interface. So user interface to perform our operations in K8s cluster. To perform operations in the K8s cluster. So how we can set up the dashboard, guys? So we can set up the dashboard by using the by using now if you install the open lens and the kube config, right? The in the Kubernetes cluster. So there is a kube config file is there. In that kube config file, copy that kube config file and install the open lens and add that kube config file into the that open lens, guys. Guys, understood? or else something like a Kubernetes web dashboard. We can set up the dashboard by using the so recommended AML, something like yeah, guys. One invalid request. Recover GitHub. Slash Kubernetes slash Kubernetes. Yes, Kubernetes. Kubernetes public GitHub licenses API change log. What is this change log, guys? What this is the cluster, guys. Cluster add-ons, images, cube mark, load dump, public existing, skeleton. This is the skeleton, guys. Owners, the skeleton label. Yeah, guys. Kubernetes, then dashboard, 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 dashboard slash v2.5.0 not found. So here Kubernetes it is dashboard dash. Enhancement cloud provider GCP release test infra cops call ingress node problem detector community ingress and JNX. Yeah, this is the ingress and JNX, guys. You can check with this. This is the ingress. Ingress we'll discuss tomorrow, guys. No worries. So these are the QBADM autoscaler. Yeah, autoscaler. In the autoscaler, create a cluster autoscaler. Cluster autoscalers, cloud providers, config context. Yeah, guys, you can go through this documentation also. This is a Kubernetes documentation. Okay, vertical pod is autoscaler and a horizontal pod autoscaler. So this is the autoscaler dashboard. Yeah, so this is the dashboard, guys. Yeah, Kubernetes dashboard and V2. Yeah, so this is the example of the dashboard, guys. So this is the example of the a dashboard, CPU dashboard. So cron jobs, daemon sets, deployments, jobs, pods. So here also, so this is the Kubernetes dashboard. So this is also a Kubernetes dashboard. So you can use this dashboard to to monitor from the to monitor on the dashboard. You see, so the CPU requests and limits, memory requests and limits, pod, so pod allocation, pod allocation. Guys, got it? So edit the Kubernetes dashboard service and change it to the node port. Check which node Kubernetes dashboard is running. So access Kubernetes web UI dashboard using the URL node public IP and node port. So create admin user with the below YAML file. Something like we can create that users, right? Yeah. So this is the dashboard, guys. You guys can go through it, go through these docs, right, guys? So we can go through this documentation dashboard. This is the dashboard, guys. Yeah. So this is the a dashboard. Yeah. Kubernetes dashboard. If you want, you guys can read it, the documentation. Okay. Yeah, guys. So tomorrow we'll discuss about the Kubernetes ingress, guys. So after ingress, we will wind up this session. Okay. So in case we already discussed it, right? So the ingress. So ingress is used to map the external URLs to Kubernetes cluster service. Pods are accessing with the class within the cluster. To expose pods outside the cluster, we are using the service concept. We have a three types of services in Kubernetes: cluster IP, node port, and LBR. We already discussed it, right, in the service. So cluster IP, node port, and load balancer. So ingress examples. These are the ingress. So we'll discuss, guys. We'll discuss tomorrow the ingress. Okay. So Kubernetes ingress is a collection of routing rules that govern how external users access the service running in the Kubernetes cluster. So deploy to applications into Kubernetes cluster using the cluster IP. So it will connect internal. Cluster IP is nothing but so it will connect to the internally only. If you want to expose outside, we need to use the node port or a load balancer. Now we have two services running our Kubernetes cluster with a cluster IP service. You cannot access the outside of the cluster. So we will use Ingress to provide a routing for these two services from the external traffic. So Kubernetes Ingress is the resource to add rules to routing the traffic from external resources to the services in the Kubernetes cluster. So Kubernetes cluster Ingress, I will show you guys. We'll show you tomorrow. So the Ingress setup and the Ingress setup and the deployment or a daemon set. Then LVR, we can create the LVR and path-based routing. So path-based routing, guys. Okay. So we'll show it to tomorrow. So mostly we will wind up the tomorrow, guys. The Kubernetes. Then we will start the CI/CD. GitLab, our CI/CD is a GitLab. So how we can install the GitLab? You already knows, guys. You guys can set up a account in the GitLab, guys. GitLab also you can set up a account. So once account, we create a new project and so we can clone the data and we can create the pipeline. Something like this is the pipeline, guys. So .gitlab.ca.aml. So in this pipeline, it will be, you see, pipeline is running. So while running the pipeline, what are the components are working? So we'll show you guys. Okay. So we'll wind up the ingress tomorrow and we'll start the CACD. Okay. Guys, understood? Okay, guys. So we'll continue from tomorrow.